Hello AP Statistics students, it's Mr. Levy, and as promised I'm coming to you with the early solutions to the 2025 FRQs. This video will cover FRQs 1 through 3. College Board just released them a couple hours ago, and I did them right away. These are the solutions to the first 3 questions. A separate video will be posted in about an hour and a half or so with solutions to questions 4 through 6. Let's get started with question 1. So in this question, this is your typical Unit 1 comparative SOX question, where we're looking at an automobile company comparing the gas mileage for cars manufactured in 2 different countries, country A and country B. And it says the manager selected a random sample of 100 cars manufactured in country A and a random sample of 100 cars manufactured in country B. The gas mileages for each sample in miles per gallon are summarized in the box plots that you see on your screen. So part A is this classic question asking us to compare the 2 distributions. And my answer says, looking at the box plots for gas mileage in both countries, there are immediate differences that are hard to ignore. The median for country A at 18 miles per gallon is significantly lower than the median for country B at 32 miles per gallon. Country A has an outlier, a car whose gas mileage is 37 miles per gallon, whereas country B's box plot shows no outliers. Country A's mileage is spread from 15 to 37 miles per gallon, a range of 22 miles per gallon, which is the exact same range as country B's, spread from 18 to 40 miles per gallon. Though the complete shape cannot be seen from a box plot, it appears the countries differ in shape, with country A's mileage appearing to be skewed right, whereas country B's mileage appears to be slightly skewed left. So again, we go through all 4 letters of SOX: shape, outliers, center, spread, and we do so in context. Part B says, for the distribution of gas mileage for the sample of cars manufactured in country A, would you expect the mean to be greater than 18 miles per gallon, less than 18, or equal to 18? And it asks for a justification. And I said, since country A's distribution of gas mileage appears to be skewed right, with a high outlier, and 18 miles per gallon appears to be its median, I would expect country A's mean gas mileage to be greater than 18 miles per gallon. The median represents the 50th percentile of a distribution, and it is resistant to outliers and skewness. I would expect the mean, which is sensitive, on the other hand, to be pulled by the skewness and high outlier to the right of the median. So we get to part C, which actually is further broken down into 2 parts, the first of which asks, what is the range of the combined data set? And this part's not so bad, and again, we have to justify. The new range will be 26 miles per gallon. Since the range is defined as the maximum value in a distribution minus the minimum value in a distribution, we need to figure out both the max and the min of the combined distribution across both countries. To find the combined maximum, we must take the larger of each country's individual maximum. Since 40 is greater than 38, the combined maximum will be 40 miles per gallon, and using the same logic, we can find the combined minimum as the smaller of 14 and 18, the minimum of each of them. To find the combined range, we subtract 14, which is the combined minimum, from 40, which is the combined maximum, to get 26 miles per gallon. And the final part of this question, what is a possible value, the median of the combined data set? This one does certainly require some thinking, and it asks us to justify our answer by referencing the box plots shown. So I said I would infer that the combined median would be very close to 24 miles per gallon. The new median will take place between the 100 and 101st value in the ordered combined distribution, and that's because the combined distribution will have a total of 200 values. Since 24 miles per gallon is Q3 for country A, we expect 75 of the 100 values from country A to be less than or equal to 24 miles per gallon. Since 24 miles per gallon happens to also be Q1 for country B, we expect 25 of its 100 values to be less than or equal to 24 miles per gallon. As such, we expect 100 total values in the combined distribution to be less than or equal to 24 miles per gallon, making it a great estimate for the median of a distribution with 200 values. All right, that's question 1. We're on to question 2. And in this question, we are looking at 3 different sampling methods. So we're on to unit 3. And they tell us that we have these tiny insects that feed on plants like cabbage plants. They're called aphids. And farmers want to reduce the number of aphids in a cabbage field. And in this particular design of the field, the farmer's house is furthest from a river, which is on the other side of the cabbage field. And the farmer thinks that potentially the closer you are to the field, the more aphids there are going to be in the same area. And so what he does is he splits up the cabbage field into a grid of 25 regions, and you can classify these regions by rows. And each row there are 5 regions from left to right, and they give you 3 sampling methods, methods 1, 2, and 3. Part A says, explain whether sampling method 1 is an appropriate sampling method for the farmer to use to estimate the proportion of cabbage plants in the field that are damaged by aphids. And I said no, since the farmer believes that the extent of the aphid damage is greater for the regions in the cabbage field closer to the river, using just region 3, which is what's proposed by sampling method 1, would not provide a representative sample from which he could estimate the proportion of cabbage plants in the field that have suffered damage from aphids. This would very likely lead to an underestimate of the proportion of plants suffering aphid damage, as region 3 is furthest from the river. Please keep in mind that once I answered the question, I then read part B, which was asking for an over and underestimate. I'm not sure that you're going to have to say an underestimate in this part because they're explicitly asking for it in the next part. So it might just be okay to say that it is not appropriate, and the reason being that it's furthest from the river. That might be enough to earn you an E on this part. Part B flips to looking at sampling method 2. And it says, using sampling method 2, the farmer randomly selected row E and examined every cabbage plant in row E. If the farmer's belief is correct, determine whether the selection is likely to provide an overestimate or an underestimate of the proportion of cabbage plants in the field that are damaged by aphids. And again, it wants us to justify. So far, these first 2 FRQs have been very heavy on writing, very heavy on the use of reasoning and justification. So since row E is closest to the river, the farmer will likely overestimate the proportion of cabbage plants in the field that are damaged by aphids, assuming his belief is correct, as a higher proportion of damaged cabbage plants would be expected in row E than rows A through D due to their increased distance from the river. Final part of question 2 takes us to sampling method 3, and it says, using the information provided in the diagram of the cabbage field, describe how to implement sampling method 3, which requires a random selection of 1 region from each of the rows. I said I would make 5 equally sized slips of paper that are numbered 1 through 5, corresponding to the regions from left to right in each row. For each row, I would mix the slips in a bucket, choose 1 slip, record its number, and place it back into the bucket. I would examine every cabbage plant in the 5 regions corresponding to the 5 selected slips. And please note, on the 3rd selection, and this is just an example, I could have used the 2nd, 3rd, 4th, or 5th, but I said, please note on the 3rd selection, and in parentheses I'm saying for row C, choosing number 3 actually means that the region that I would select is the 3rd from the left. So in row C, the 3rd from the left is region 13. And again, I'm just doing that to avoid having to make 25 slips of paper and having to use 5 different ones for each row. This way I can just use the same 5 for all 5 rows. On to question number 3, and this time we're looking at songs being played at a restaurant, sort of at random, and they tell us there's 1,000 songs that you could choose from, and again, they're going to be randomly played, and they split those songs up by genre, so we know that there's 200 country songs, 400 pop songs, 100 rock songs, and 300 jazz songs. And a very, very key sentence here is that any song can be replayed at any time, and that to me screams independence. So the song that's currently being played is independent of any song that's been played before or that will be played after. Part AI says, suppose one song is selected at random to be played. What is the probability that that song is a rock song? It asks us to show our work. So I'm just defining the word rock as an event that represents a rock song being chosen to be played. And the number of rock songs is 100. The total number of songs is 1,000. And again, they're all equally likely. So 100 over 1,000 is our probability, 0.1 or 10% chance of a rock song being played. AII asks, suppose 2 songs are selected at random to be played. What is the probability that both songs are rock songs? And it asks us again to show our work. And again, because they're independent, the probability that a rock song plays and then another rock song plays right after is the same as just the probability probability that a rock song plays times itself, okay, or 0.1 squared, which gives me 0.01 or a 1% chance of this occurring. Part B, in every 1 hour period, 20 songs will be played. So we're getting new information. At random, 20 songs are being played, and any song can be replayed at any time. Again, independence. Ms. Fay is interested in how many rock songs will be played in a typical 1 hour period. Define the random variable of interest to Ms. Fay and state how the random variable is distributed. So Ms. Fay is interested in X. You can pick any letter, a random variable that represents the number of rock songs that will be played in a typical 1 hour period. We know because we check bins, okay? Each song is either, it's binary, right? It's either a rock song or not a rock song. We've established that there's independence. There's a predetermined number of trials, so 20 songs are going to be played each hour, and they all have that 1 in 10, the 0.1, independent probability of success. And so I said X follows a binomial distribution with n equal to 20 and p equal to 0.1. And again, this is not going to be required, but I said, fun fact, the shape of X is skewed right. And I know that because the large counts condition is not met, n times p equals 2, which is far less than 10. Okay, so there's no sense in checking n times 1 minus p, but we know that when the large counts condition is not met and p is close to 0, the shape is going to be skewed right. And BII asks, what is the expected value for the random variable in part B? Okay, the expected value of a binomial variable is n times p, so that's the 20 times 0.1, which gives me 2 songs. Finally, we have part C, and it's again reminding us that in every 1 hour period, 20 songs will be played at random, and any song can be replayed. It asks us to determine the probability that 4 or more rock songs in a particular 1 hour period will be played. And again, the probability that X is at least 4 is 1 minus the probability that X is at most 3. And I can use binomial CDF if I have a TI-84 calculator. It's just very important to label these parameters. So N is 20, P is 0.1, and X is 3, and I get 0.13295. In the last part of this question, it says, suppose 4 rock songs are played during a particular 1 hour period. Do we have strong evidence that the song selection process was not truly random? And it asks us to justify without performing an inference procedure. And I'm saying no. Since the probability that X is at least 4 is approximately 0.13, which is more than all reasonable significant levels, we do not have strong evidence that the song selection process was not truly random. In fact, 13 out of every 100 times that you would do this, we'd expect 4 or more rock songs to play in an hour by chance alone, which is not super uncommon at all. So that wraps up questions 1 through 3. And again, I'll be posting in the next hour and a half questions 4 through 6 in another video. I look forward to seeing you then.